All right. So in this question, we have been given a block which is kept on an inclined plane. So it's mentioned three forces act on the block which is sliding down at constant speed. W is the weight which is acting downwards. R is the reaction force, normal reaction. And F is the force of friction. So we need to figure out which of the options gives the right statement. So this question is actually extremely easy if you can focus on the keyword of the question. So the keyword is in the first sentence. It's given that the block is sliding down at constant speed. So the word constant speed is the keyword because if the speed is constant, which means velocity is constant, and let us write this down. So if the velocity is constant, we can say the value of acceleration is equal to zero. Why acceleration is zero? Because acceleration is rate of change of velocity. So if velocity is not changing, acceleration will be zero. Now we go to the Newton's second law, which states that F net is equal to m into a. So if the value of acceleration is zero, so the value of net force will also be equal to zero. So this means whatever forces are acting on the block, the end result, the net force of all the combined forces should be equal to zero, which is only mentioned in option D, which states that the resultant force on the block is zero. Hence, we can say the answer is actually D. But in any case, let's see how the other options are incorrect. In option A, it's saying there must be an unbalanced force down the plane. Is it actually true? To do that, what we'll do, just analyze the figure. We have contact force, friction force, and the weight acting downwards. So we will break the weight W into two components. So watch, one component of weight will go along this arrow and the other component of weight will go along this arrow. Let's call this as Wy and this one as Wx. Option A states that there must be an unbalanced force down the plane. Is it true? Not really. Because if you look along the plane, we have a force of friction acting upwards and the Wy acting downwards. Now, since the speed is constant, which means acceleration is equal to zero, and hence net force is zero, which means forces have to actually cancel each other out. So, the value of F, let me write it down. So, the force of friction should be equal to the downward force Wy, and the force, normal contact force, the normal reaction R should be equal to Wx. So let's write that down. R is equal to Wx. So along the plane there is no unbalanced force because F and Wy are cancelling each other out. Hence option A is incorrect. In option B it is saying W is equal to R. Is that correct? So no, W is not equal to R. In fact, R is equal to the component of W which is perpendicular to the plane, which is Wx. So R is the x component of W. Just to simplify this, let's say the angle of the incline, let me draw, let's say this angle is theta, which means this particular angle will also be theta. Hence, we can say that Wx will be W cos theta and Wy on the other hand will be W sin theta. So now we can write the value of F is equal to W sin theta and the value of R will be equal to W cos theta. So F and W are not equal. R and W are also not equal, which means option B and option C are also incorrect. The only correct option is D, which states that the resultant force is zero. And why is that happening? Because the acceleration is zero. And why is that happening? Because the speed of the block is constant. And that's how we solve.